Hi, Mr. Morrow.
Hello. Can everybody hear me?
Yeah.
Okay. Okay. So we got one, two, we got. Oh. I'm pretty sure. We got everybody na 6, 7, 8. Anybody who's with somebody, or is everybody on their own?
I'm personally on my own.
Okay.
I am also on my own.
Mr. Mora, me and Reina are together.
Oh, okay. Zoe?
Yeah, and Reina.
Hi, Mr. Mora.
Oh, hello. Danny, any news for, does anybody know where Kaylee is? Is he gonna be with us or?
I talked to her about class like 30 minutes ago, so I think so.
Oh, okay. Okay. Okay, guys, let's, I think we could begin. Let's give Kaylee like another 2 minutes more. And then for now, let me just. Can everybody see my screen?
Yes.
The blue screen? Oh, okay. So, yeah, let's just begin by 5:02. And then, well, first we're just going to have some. Oh, yeah, guys, just a reminder for the day class. This one will end, and this one will go all the way to May 29. However, for those who are taking up dual class, we are still going to go until for your college classes, whatever is the grade that you'll have on the 4th of May, that will be for your that will be the grade that I will be giving you for your college courses with Miss Manzanares. However, this class will still go all the way until the 29th of May, or before the 29th of May. So that's gonna be on May 29 is Friday. So technically by the 28th of May, I'll be able to give all your final grades. Okay, any questions, clarification so far with the classes?
So will that the college grade, that's just for college, that's not for our high school GPA? Like for me,
Not
Danny,
for your,
it will
not
still have to stay in the class.
everybody will still be on the class until May 29.
Oh, that sucks.
Yeah, it really does. I thought our last day was going to be in 2 weeks.
That's what I thought too.
Disappointment after disappointment.
I'm so sorry, guys. Just the bitter, never kill the bitter of the bad news. Oh, here we go. Because
Don't kill the messenger.
just don't kill the messenger. It's just me. Okay, but still for the night classes, for the dual class, you will have whatever is going to be your grade on the 4th of May. That will be the grade for your college course. Otherwise, as what they have told us, classes will go all the way to the 29th of May. Other than that, they haven't told us anything yet. Okay, so guys.
And right now,
yes.
Kaylee's unavailable. She said she sent you an email.
Okay, I haven't read it first. Okay, I'll just read it later. Okay, so guys, thank you for that, Danny. So we begin. I guess Ashley's. Yeah, Ashley's here. Okay, so guys, let's begin. So for today, we are going to have our objectives for today. We are just going to discuss Reiman's midpoint and trapezoidal sums. Okay, so when we talk about Riemann sums, okay, last week we were just like we were considering your left and your right side of your. Everybody okay? Okay, let's go back. So again, so last week we were able to discuss Riemann sums, okay, and we were just considering the left and the right side of the rectangle that we're going to take into consideration. So we did notice that for the left and right side, it could either be an overestimation or it could either be an underestimation of the area that is under consideration. Now, for this week, we are going to step it further where let's try to make it a little bit more precise, or a little bit more closer to the actual or the estimated area of the given function underneath the two boundaries. Okay, so for today, we're going to discuss the midpoint and the trapezoidal sums. Questions, guys, clarifications with our objectives? Shall I continue?
Yes.
Okay. So first things first, let's talk about the midpoint. And if you've noticed, the midpoint is almost very, very similar to the trapezoidal sums. Okay, midpoint sum. Okay, so guys, if you were able to, like, I guess for everybody was able, well, some of you were not able to look at the video. So again, this is just the iteration of the video that I assigned to you, okay, last week. So let me just try to draw a given function. Okay, let's just try to call this, I guess. I think this was y is equals to x squared plus 1. Let me just draw. Okay, so let's say we have the function f of x is equal to x squared plus 1. And let's say we wanted to get the area bounded by, I guess, this is from -1, 0, just to a really, really good approximation of my lines. Okay, so let's say we have this function right here, which is being defined as f of x is equal to x squared plus 1. Now, let's say we want to find the area bounded by -1 and +2. And let's say for the area, let's say we want to, in this case, let's try to divide this into 3 rectangles. Okay, so 3 equal rectangles. And let's try to use our midpoint sum in order for us to approximate the area of the function x squared plus 1 that is bounded by your 2 and your -1. So let's start with our delta x. Could somebody still remember what's the formula for our delta x? Anybody?
Is it the one where, I forgot, sorry.
That's okay. Okay, try it out. So what's going to be your delta x? Just a reminder, if you want to see a graphical representation of our delta x, this is our
X of
delta x.
x
Yes.
of 2 minus x of 1 over your number of rectangles.
Very good. So you have x of 2 minus x of 1 divided by the total number of rectangles. So number of rectangles. So in this case, this would just translate our higher, which is our x of 2, will give us what? Wyatt? What's going to be our x of 2 for this one? Oh, Wyatt?
Sorry, I'm having a brain fart.
Okay, what's the highest boundary of our area? What's the value of our x on the highest boundary?
2.
2. So you'll have 2, okay, minus, okay. What's the lowest boundary for this one, Zoe? Now, where's Zoe? Anybody? Zoe and Reina?
Is it -1?
That's going to be -1. Very good. So that's going to be -1 over. So how many rectangles are we supposed to have for this one, Savannah?
3.
How many rectangles? Got 1, 2, and 3. So how many rectangles for this one, Savannah? How many number of rectangles do we have? Oh. Savannah there? Yeah, Savannah should be here. Guys?
I think she
Anybody?
texted me that she was having connection issues because she couldn't hear you
okay.
at first.
Oh, okay. Can we try Ashley? How many number of rectangles? Yeah, so we're going to have 3. So therefore, if we're just going to simplify this, our delta x for this one, Danny, what's going to be our delta x for this one?
1.
So that will just give us a value of 1. So,
Wait, Mr. Mora,
yes.
the first delta x, what's under x? What's under like the first fraction?
Oh, okay. It's a total number of rectangles that we're supposed to have. So in most cases, like for every problems that we're going to have, it's going to be stated how many times we're going to divide it in terms of rectangles beneath our curve.
Okay.
That makes sense?
I was just curious on that part because
That's okay, no problem. Anyway, we're going to have some more examples with this one and sometime later. So guys, our delta x is 1. Okay. Now, what we're going to do next is, okay, we are now going to use the idea of the midpoint sum. Now, again, from last week, if we're going to find the area, we're technically just considering one side. So we could either consider the left side or the right side of our rectangle. Now, in this case, we just wanted to consider, okay, what we want to consider right now is we're going to get the midpoint between our two sides. Okay? Yes.
Reina just texted and she said that her and Reina can't hear you and it keeps cutting off.
Oh, okay. Can you like maybe just ask them to log out again and then try to sign in?
Okay.
Okay. That makes sense? Okay, shall we continue? So again, guys, when we talk about midpoint sum, okay, what we want to do is we want to find the midpoint, okay, the value of our x in between, or the value of our f of x in between our two sides. Okay, so let's just try. Okay, so again, going back, okay, on our problem, we actually have 3 rectangles. So again, our equation for this one is, it would still be the same. It would still be f of x multiplied to delta x, the summation of what f of x multiplied to delta x. Now, let's take a look at this part. So for the area, okay, this one will just give us, okay, our f of, okay, guys, what's in between for our first rectangle, okay, what's going to be in between -1 and 0? So what's in between -1 and 0?
-1/2.
-1/2, or yeah, let's just have it as -1/2. And then for the rectangle, we multiply that with delta x, okay, plus, okay. Again, that's for the first rectangle, okay. Let's take a look at the second rectangle, guys, okay. So in this case, that's going to be the function, our f of x will now be therefore what's in between your 0 and +1. Okay, Ashley, do you have
0.5.
any? It's going to be 0.5, or in fraction, we're just going to use 1
Wait,
over
Mr.
2.
Mora, does it matter
Yes.
if you use a fraction or 0.5?
I think
It
fraction makes it easier.
Okay.
Okay. Yeah. The fraction will make it easier as if you could see that if you take a look at our function, it's a very, very simple function that right away we could just blurt it out. Again, if you want to do decimals, that's perfectly fine. But sometimes if you want to, it would make it irrational for some equations. In this case, this is a very, very simple function that we're given, so I guess fraction would be okay for us. That work?
Yeah.
So again, it all depends on the type of problem that you have. In this case, in most cases, like for the can problems, it's mostly just in fractions would be enough. Okay? So we're done with our second rectangle. Let's take a look at our third rectangle. So guys, what's in between 1 and 2? What's going to
3
be
over 2.
3 over 2. Does everybody understood where we got your 3 over 2? Would anybody would like to clarify where we got the 3 over 2? How did we came up with the 3 over 2?
3 divided by 2 is equal to 1.5.
1.5. Very good. So we got 3 over 2 delta x. You guys good? So guys, what's our next step? If you take a look at all of this, okay, what can we factor out? Mateo, what do you think can we factor out? What's common between these three terms?
Triangle of x.
The triangle of x, or the delta x? Delta x.
Delta x, yeah.
Okay. Have you guys played Delta Force before, or was it too old for you guys? Never
Is
mind.
that the one where you like? No, wait, that's asteroids. Never mind.
Kind of like very, very similar to, I guess, Counter-Strike. Okay, never mind. Let's proceed. Okay, so what do we do with your -1 over 2 for your function of -1 over 2? So all you need to do is just replace, okay, your x with -1 over 2, and then solve for your f of x. So guys, I'll be assigning for the f of -1 over 2. Brandy, can you do this for the -1 over 2? For the function of 1 over 2, can you do this one for me? Ashley and Savannah, are you okay there? Can you do 3 over 2 for me, please?
Wait, so Mr. where I'm solving for the first one?
Yes, for the first one, just replace your -1 over 2 with your x on our given function. And then who did I call for 1 over 2? Was it Ashley?
Yeah.
Okay, and then for the 3 over 2, can we have Savannah?
Yeah.
Okay. And then for, and then for the rest, if you would like to follow along, that'd be fine. And then let's give you guys like about 1 minute. That'd be good. You guys not getting bored?
Oh yeah, I'm very bored, Mr. Mora.
I've been bored since the second week.
Oh my.
Wait,
since the first
Yeah,
when did
me-
you last day of school?
The last time, that was March 12 or 13?
13.
I don't know. The last
That
day
was
I
the
have notes from is March 10th. So I think.
Okay. That could be it. Oh my.
Dang, over a month.
Yeah, I think I'm gaining 1 pound every day.
Me too.
Okay, Brandy, you done or not yet? Brandy, Brandy there? Anybody heard about Brandy? What happened to Brandy?
She's
Brandy's
no
good.
longer in the participants.
Yeah, what happened? I wonder what happened to her. Danny, could you like maybe? Yes.
I know that on my side, I keep like it's buffering and stuff, and it's like trying to kick me out. So it might be happening to everybody.
Oh, okay,
Yeah,
okay,
it's
okay.
also very windy here, so she might have lost connection.
I'm having a hard time connecting you.
Oh,
Yeah, it's
okay.
bad.
Okay.
Mr. Moore,
Yes.
Brandy said that her thing kicked her out, so she's logging in again.
Oh, okay, okay. I'll just wait for her. So, Danny, could you like maybe make up for
5/4.
So you have 5/4. Okay, and for Ali, do you have like the answer for your part?
Okay, so that one was mine, but isn't it 5
Oh,
over
yeah,
4
yeah.
as well?
Very
Yes.
good. Very
Yeah.
good. Yeah. Again, if you square, whether it's if you guys have the same value, whether it's a negative, whether it has a sign of a negative and the other one is a positive, if you square both items, still likely have the same answers. That's why you got 5/4. You also have 5/4, and then for what was our 3/2? Was that Savannah? So Savannah's not here too. Okay. Could anybody like maybe do the thing for Savannah? Anybody, guys?
23/4.
3/4.
23.
23/4. 23/4 for like this part.
Yes.
Mm.
No.
Wouldn't it be 13/4?
13/4. Yeah.
Okay. 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 So it's gonna be 13/4. Okay. So thank you for that, Wyatt. That's okay. I think I know what you're going into, Danny. I think you might have some extra notes there. If you add all of this, guys, all of this,
you get 23.
You get 23/4. So therefore, our area, by the way, the delta x, just a reminder, a delta x for this one is equal to 1. So therefore, 1 multiplied to 23/4. So therefore, that would just give us 23/4 square units. Or if you think that's improper, the mixed term for that would just be 5 3/4 square units. Okay, questions, guys? Clarifications?
That's the final answer.
That's the final answer. Would you like to maybe like take a screenshot, make a copy, and then I'll delete it afterwards? We could do like 2 examples for each midpoint, and then we're going to proceed with the trapezoidal sums.
Wait, Mr. Morrow, can you hear
Yes.
me? Is it working?
Yeah.
Okay, I don't know what happened. I don't know.
That's okay. We're in the rural part, guys. It's bound to happen.
Okay.
That's okay. Can I delete? Can I delete everything? And then let's move on. Okay, so I'm going to delete now. We're going to have some more examples. You can, let's see. So let's take a look at example number 1. Can everybody see it clearly?
Yeah.
Okay. Okay, so let's begin. Let me just transfer this part here. This part here. I'll just stick to my. Okay, never mind. Okay, guys, let's begin. Okay, so we have here, again, this is just like one of the work that you guys are going to be doing on CAN. So we have here the f of x has the function of x minus 3 squared, or quantity squared, from, so we want to find out the area bounded by x equals 0 to x equals 6 using the midpoint. Okay, Reiman sum with 3 equal subdivision. So again, guys, this is 3 equal subdivision. So we would be therefore very, very easy for us to find our delta x. So in this case, Mateo, can you help me out on finding our delta x?
Would it be like we're trying to get it away? Take it away? Or
we're looking for the value of our delta x. What is it gonna be?
3? I don't know.
Yeah, what's the highest value of our x sub? So we're going to have x sub 2 minus x sub 1 divided by the total number of rectangles that we're going to use. So what's our highest value for our x, the boundary?
6.
So you'll have 6 minus, what's the lowest?
3.
In this. Take a look at it again.
Oh.
Our boundary is from, these are our boundaries. These are our boundaries. So what's our lowest value of our x?
0.
0. How many rectangles do we need to have?
3.
So we're going to have 3. So therefore, in this case, you have 6 minus 0 over 3. What's going to be our delta x for this one, Mateo?
6 over 3. So it would be, hold on. 2.
2. Very good. So their delta x will just be equal to 2. Now, if you notice it quite, if we then take a look at these boundaries and then if we divide it into 3 equal parts or 3 equal subdivisions, we notice that we do have a count of 2 on every subdivision. So therefore, again, guys, delta x is equal to 2. Our area for this one will just be equal to, okay, we're just going to add up all our subdivisions. So that will be f of, okay, let's take a look at our first subdivision. Okay, it's from 0 to 2. So what's going to be in between 0 and 2 for this one, Wyatt? Oh, Wyatt? What's going to be in between 0 and 2?
Sorry, say that question again. It cuts out.
Okay, so that's okay. So again, let's take a look at our 3 equal subdivisions. So we're now going to find the area of our first subdivision. So what we're going to do is we're going to find out what's going to be in between your 0 and 2. What's the value in between 0 and 2?
Sorry, is it a 2?
Okay, again, take a look at what's in
I'm
between 0.
sorry. Well, in between 0 and 2 is 1.
1. So therefore, you have
Yeah.
f of 1.
Oh, okay.
Very good.
Oh, okay.
Delta x plus, okay. Next part is we're going to take a look at this triangle. Well, it's a really, really small triangle. I mean, rectangle. It's a really, really small rectangle. So it's bounded by your 2 and your 4. So what's going to be in between your 2 and your 4? For this one, let's try to call on Ali. What's in between 2 and 4? Very good. So you'll have 3. We're still going to multiply it with delta x plus, okay, this is now our third, okay, rectangle, okay, so it's bounded between 4 and 6. So what's going to be in between your 4 and your 6? Brandy?
Hi.
What's in between 4 and 6? Very good. So you'll have 5 delta x. Next part, we're just going to factor out what's common between all of these 3 terms, guys.
Delta x.
Very good. So you'll have delta x multiplied by f of 1 plus f of 3 plus f of 5. Okay. So in this case, I would like, okay, our delta x will just be 2. Now let's try to divide our labor, guys. For f of 1, can we have Ali for f of 2? Brandy, would you like to have another go?
Yeah.
I mean f of 3. And
Yeah.
then for f of 5, can we have Wyatt for f of 5? I'll give you guys like about 1 minute.
Wait, what am
solve.
I doing now, Mr. Mora?
Who was that? Is that Ali or
No,
Ali or is that Brandy?
No, that's Brandy.
Brandy. Okay, Brandy, you'll be doing f of 3. So you're gonna be doing f of 3. Ali, you'll be doing f of 1, and then for Wyatt, you'll be doing f of 5.
Mr. Moore, would the first one just be 2?
2. Let's see. 1 minus 3 is.
Oh, never mind. I forgot about that 3.
Okay. That's okay. No problem. Then don't forget also, you still get to square. Okay?
Would it be -4?
Okay. Every time you square, there's no negative. There will always be. It will always. So it will be
4.
4. Okay. And then let's Brandy. You were able to do for your part.
Would it be 3? I have to do 3 minus 3 squared.
Yes. What's 3 minus 3 squared?
0.
0. Very good. And Wyatt?
Would it be 8?
8? How did you came up with?
Because I did 5. Oh, sorry. That's after you multiply. It's 4.
Okay. So you now have.
Sorry, I multiplied it by 2 already.
That's okay. So in this case, Mateo, can you total it all for us? 4 plus 4. What's going to be our area for this one, Mateo?
16.
16. So that will just give us 16 square units. You guys good? So that's the answer for this problem. Questions, guys? Clarifications? Anybody? Can we move on? You guys good? Oh, Zoe is still there. Okay. Okay. Would you like to have another example for the midpoint, or can we now proceed for the trapezoidal sum?
We can proceed.
Proceed. Questions, guys?
Wait, let me screenshot this.
Okay.
All right, now you can proceed.
Okay. Any more questions? Can we proceed? Anybody would still like to do a screenshot? Nobody. Okay, so I guess let's proceed. Okay. Okay, guys, so let's begin. So for now, so let's now continue with the trapezoidal sum. Oops. Okay, so let's now proceed. Reiman's trapezoidal sum. Okay, now for a quick, could anybody like tell me what does a trapezoid look like? Anybody?
A rectangle with a triangle at the end.
A rectangle with a okay, it's a fusion between a rectangle and a triangle at the end. Okay, yeah, that'll make sure. So that's just gonna be, this is what a trapezoid would look like. You could either have it this way. Right, so this is what, it's a technically just a combination of a rectangle plus a triangle. Now, let's discuss first, what's going to be the area of a trapezoid? So we're just technically going to, before we proceed with anything, yeah, that's my wife right there, just going right. Okay. So guys, any idea of what an area of a trapezoid is? What's a general area for a regular trapezoid? Ideas?
A plus B over 2.
A plus B, yeah. A plus B. What else? Almost there, Savannah. Almost there.
Over 2 times H height.
A plus B over 2 times 8.
A plus B over 2 multiplied by its height. So it's just going to be, okay, so let's say in this case, now it's not technically the height, but in this case, it's going to be our base. Okay, we're just going to add.
Hi, Mr. More. This is Mariana. Hi.
Hi, Miss Mariana. Hello. Okay.
So long.
Okay, so again, guys, it's just that we're just going to add the two heights. Okay, so that's going to be A plus B. Okay, and then since we're just going to get the average of our two heights, so if we try to do the normal average, we're just going to divide it by 2. So again, the area of a trapezoid is going to give us, let me just erase that one. So that's going to give us height 1. In this case, that's going to be our A plus height 2, which is going to be our B. We divide it by 2, and then we multiply it with our base. So that's the area of our trapezoid. You guys good with that? Questions, guys? Clarifications with the area of the trapezoid. Again, we're just like, this is just going to be like the very first part. And then let's try to solve some problem using this idea right here. You guys good?
Yeah.
Questions, clarifications? Can I erase this part?
Yeah.
Okay, so don't forget.
Hold on 1 second. Hold on.
Okay, all right. So again, area of a trapezoid, that's just height 1 plus height 2 divided by 2, okay, multiplied by its base. It's good?
Yes.
Can we, can I erase?
Yeah.
All right. Okay, so let me just add an image right here. Let's try to do, that's, you guys won't be able to. Okay, let's do this first. Okay. Okay. What happened? Let me do that again. Add image. Trapezoid 2. Ah! Okay. Oh, okay. It's not getting any bigger. Can everybody see? Or do you guys want to make it bigger? Like that?
Yeah, that's fine.
That'd be good. Okay, guys. So again, we're just going to find, in this case, we're not going to use the idea of what? A trapezoid, or using the idea of a trapezoidal area. So just for a quick, okay, so we're going to divide this into 4 equal sides. We're going to deal with the equations later. I'm just going to give you guys like a rough, very rough. So if you notice, if you notice, if we're going to use the trapezoidal values, this is what we're going to get. This is the area that we're going to get. So it's a little bit more accurate in this case. Okay, so it's a little bit more precise as compared to the other formulas that we did earlier. So let's proceed. Okay, again, guys, delta x, the formula for the delta x, since this is an equal subdivisions, the delta x would still be the same. So in this case, Reina, can you please give me what's going to be our delta x? What's the formula for our delta x again? Just the basic formula. Reina there? Okay, Reina's not here.
x2 minus x1.
Okay, very good. So x2 minus x1 divided by?
The number of triangles?
The number of triangles. So total number of, not triangles, but rectangles. Okay, Savannah, your turn. So can you please give me what's the more specific delta x equation for this one?
Would it
What's
be
the highest? Would it be? What's the highest boundary that we have? Choose between these two.
6.
So you have 6 minus the lower boundary is?
2.
2. How many equal subdivisions do we need to have?
4.
4. So you have 6 minus 2 over 4. And then for this one, Ashley, can you please give me what's the value of our delta x?
It'll be 1.
Yeah, it will be 1. Very good. So we now have our delta x will just be equal to the value of 1. Now, let's us now try to get the area. Okay. So let's take a look at, okay. So let's take a look at first our first trapezoid. Okay, this is our first trapezoid. Okay. The value of this height, so it's bounded between 2 and 3, right? So it's bounded between your 2 and your 3. Now, let me just write it here just for you guys to remember. That's going to be height 1 plus height 2 divided by 2 multiplied by its base. We all know that all the bases that we're going to have will just be delta x. Now, take a look at our first trapezoid. This trapezoid right here. Okay. How would we define our H1?
3.
How would we define our H1? This is our H1. So what's it? The answer is 3, but how did we do do that again. What is it? What's gonna be our g of x?
F of 2.
F of or g of?
2.
G of 2. Okay. So guys, that's gonna be g of 2 plus what's our second height? That's gonna be in terms of, guys, what's gonna be
G
this
of
part?
3.
That's gonna be g of 3. Okay. Divided by 2. Okay. And then we multiply that with delta x. Okay, that's for our first trapezoid. Let's take a look at our second trapezoid. Okay, so Ali, what's gonna be our first height for our second trapezoid? This is gonna be our second.
G of 3.
G of 3, very good, yeah. Excellent, so you'll have G of 3 plus,
G of
what's
4.
gonna, very good, G of 4.
All over 2.
All over 2 multiplied by?
Multiplied by delta.
Yes, delta x, very good. So we were able to produce, or we were now able to we're now done with our second trapezoid. Let's take a look at our third trapezoid. Mateo, can you give us what's going to be the formula for our area of our third trapezoid? Are you there?
What was that, Mr. Mora? It was cutting out.
Oh, that's okay. What's going to be the formula for our third trapezoid? So we're now looking at the third trapezoid. This is our third trapezoid. What is it going to be? What's the base? What's our, I mean, not base, but what's our first height? Take a look at where does it go? G of what? What's the value of your x? Mateo.
I think he's gone.
Oh, he's gone. Okay. Anybody else would like, Ashley, would you like to try it out? The third trapezoid?
So it'll be G of 4
Very good. G of 4 plus?
plus G of 5 over
G,
2.
Very good. G of 5 all over 2. Multiplied
Times
by?
delta x.
Very good. Delta x. Okay, let's go all the way. I'm just going to place the last part. So we're done with our third rectangle. Wyatt, can you give me our fourth formula for our fourth trapezoid?
Would it be G of 5 plus G of 6 over 2?
Okay, so you'll have
Times
G of 5. Very
delta
good.
x.
Very good. So G of 6 all over 2 delta x. Okay, now for the next part, guys, it's going to be a little bit long. Okay, guys, what can we factor out? Anybody, what could we factor out? What's common between
Delta
all of
x.
these four terms?
Delta x.
You have delta x. What else?
Yeah, have a denominator of 2.
A denominator of 2. Very good. What's that, Brandy? So you'll have delta x
Yeah.
over 2. Okay, it's good. Next step. Okay, we're just going to rewrite everything without the delta x and the delta x and the over 2, since we were able to factor it. It out. So we now have g of 2 plus g of 3. That's for this part. Okay, this part, that's going to give us plus g of 3 plus g of 4. Okay, that's for this part. The next part, this is for this part. So you'll have g of 4 plus g of 5. Okay. And then for the last part, let me use an orange, plus g of 5 plus g of 6. Guys, may I ask you to make a screenshot of this for now? Because you might need some more space. Just might. I think we might. Okay. Now I want you to take a look at, I want you to take your focus on this set of terms inside our parentheses. Okay. Do you guys notice any repetitions?
Yes.
Okay, so there's a repetition. So therefore we could technically, in terms of algebra, we could technically add them together. So do you guys see any, let me just rewrite. Okay, so I'm just going to continue. Is there any repetitions for our g of 2?
No.
No.
So that will just be g of 2. How many g of 3 do we see? Do we have? 2. So that will give us plus 2 g of 3. Okay. Plus, how many g of 4 do we have?
2.
So you'll have plus 2 g of 4. How many g of 5 do we have?
2.
That would still be 2 g of 5. And of course, let's just rewrite that. There's only 1 g of 6. So I think right now we are now ready to convert. Let me just do it everything on this side. Okay, our delta x again, guys, what's our delta x again? Anybody, what's our delta x?
1.
1. So our delta x is 1. So we say area is equal to 1 over 2 multiplied 2. So let's take a look at our g of 2. Okay, for our g of 2, okay, our g of x, our value for our g of x, if x is equals to 2, that will just give us a value of 3. So you'll have 3 plus, you still have your 2. So that's going to be 2 multiplied 2. Guys, what's the value of our g of x if x is equal to 3? What is it equal to? Guys?
Wait, what's that, Mr. Moore?
So again, we're now looking at g of 3. So let's take a look at g of 3. Okay, what's the value of our g of x? What's the value of what's the value of our y?
7.
So that's going to give us 7. Okay, plus 2 multiply 2. Take a look at g of 4. What's going to be the value of our g of x if x is equal to 4? Wyatt?
Yeah. Wait. 2 seconds.
Okay, so again, what's the value of our g of x if x is equal to 4? What is it equal to? What's the corresponding value of your g of x? 4? Or does it?
6?
That will be 6. So you'll have 2 multiplied to 6 plus, okay, 2. What's going to be the value of our g of 5? So this is now g of 5. What's the value of our g of x? For this one, Savannah.
I'm sorry, can you repeat that again?
Okay, so if we're now looking at g of 5, okay? So g of 5, we want to find the value of g of 5. So the question is, what's the value of our g of x when x is equal to 5? What's the corresponding value for this one?
4.
That would be 4. Okay, and for this one, Zoe, what's going to be our g of 6. So if our x is equal to 6, what's going to be the value of our g of x? Guys?
Hold on.
Okay. 6, what's your y? If this is 6, take a look at where does it correspond to?
4.
This is 4. Very good. So you'll have 4. And then we're just going to simplify this. So this is just going to be 1/2. For this one, guys, Ashley, would you be kind enough to give a rundown of all of this? Ashley, there?
Yeah, hold on.
Oh, okay. That's okay. Sorry. Well, okay. I think we're on the right track.
Is it 37?
37.
Oh wait, am I supposed to do the half? Wait, hold on. Hold on.
No. Just do this part. Just do this part.
Okay.
You got 14, 12, 8 plus 4 plus 3.
41.
41. So you'll now have 41 times 1/2. For this one, anybody? Ali? What's half of 41?
It is going to be 20.5.
20.5. Very good. So you'll have 20.5 square units. Questions, guys? Clarifications? Would you want to have like one more problem for the trapezoid? I know it's more, I think we're gonna take a little bit more of an hour. Can we have one more?
Yeah.
Just to clarify everything. Right? You guys might be able to see the pattern between the two. So guys, I'll give you like about a minute to screen capture this one, and then I'll erase it all, and then I'll proceed for the next example, okay? I think I'll do the table for the next part. Can I erase?
Yeah.
Okay. Let's begin. So insert that image. P1, P3. Let's do T1. So in some cases, you won't be given a table. You won't be given a graph, but rather a table. But again, guys, it would still be exactly the same. So let's proceed right away since time is running out. Let's begin by doing our delta x. For this one, Danny, can you give me like what's the rundown of our delta x right away?
Do you want the actual value or?
Is it okay if we proceed with the actual value?
Yeah.
Like the equation right away. Okay, Danny, anytime.
5 minus -1 over 3.
5 minus -1 over 3. Again, the 3 is based on the equals. So that's going to give us 6 over 3. Your delta x, Danny, is equal to?
2.
2. Okay. So we now have, okay, your delta x is now equal to 2. Now, if you notice, all your x's, okay, -1, 1, 3, and 5 has an interval of 2. That's why we do have the delta x is equal to 2. You guys good with that?
Mm-hmm.
Okay. Now, imagine, okay, I want you guys to imagine this is going to be your first trapezoid. Okay. That's trapezoid 1. This one corresponds to your g of x, your x's for your trapezoid 1. This is going to be trapezoid 2, and this is going to be trapezoid 3. Okay? This values corresponds to the sides of your trapezoids or to the height of your trapezoid. So let's proceed. So for our area, let me just change my color to a bright yellow. Again, for the area, let's take a look at trapezoid 1. Again, the area of a trapezoid is just equal to height 1 plus height 2 divided by 2 multiplied by its base. So the area for the trapezoid, the area of our trapezoid 1, that's going to give us g of -1 plus g of 1 divided by 2 multiplied by our delta x plus, let's take a look at trapezoid 2. Okay, Ashley, can you like maybe give me what's the side of our trapezoid 2? This is trapezoid 2. So what's going to be our g of
It'll be
Ashley?
G of 1
Very good. G of 1
plus G
plus,
of 3
very good,
over
all over
2
multiplied
times
by,
delta x.
very good, delta x.
Sorry,
Okay,
it's lagging again.
that's okay. Brandy, would you like to do the third trapezoid?
Yeah.
Okay.
So it would be G of 3
Very good. G of 3 plus
G of 5
G of 5 over
2
multiplied by
delta x.
Delta x. Very good. Now, Reina, what's our common term that we can factor out? What's the common terms? What are our common terms, Reina? Anybody, guys? Yes. What's the common term? Between all of these three? 2. That's 1 over 2. And the other one is? You got one. The other one is?
It would be 1 over 2 times 2, which is equal to 1.
And the other one is? What's the other? That would just be delta x, right? So you'll have delta x over 2.
Over 2?
Yes, multiplied by g of -1. So again, guys, we're just taking out the delta x over 2. You'll have g of -1 plus g of 1. That's for this part. Plus g of 1 plus
G of 3.
Very good. Next part is this part. You'll have another g of 3 plus
G of 1.
G of?
Oh,
no,
5.
that's 5. That's 5. That's 5. Okay,
Sorry,
G of 5. Okay. So that would just be delta x over 2. Now, guys, if you notice, okay, the outside, okay, the outside terms will only be occurring once. That's g of your -1. Everything, we just change that into different colors. Everything that is inside will be occurring twice. So you'll have plus 2 g of
1.
1. Very good. Let me just erase it. So that's going to be plus 2 g of g of 1. Okay, let me just do it. And then the other one is plus 2 g of 3 plus
just G of 5.
G of 5. Very good.
Mr. Mora, do you have to can you just go straight into this step, or can?
If you want to just maybe go straight into this part, that'd be fine by me. Again, over time when we proceed with integral calculus, this is like the part that we're just going to be concerned of. Again, the reason why we always want to go through this long process first is for you guys to understand where the t came from. It's almost like the same, like having the long part of getting the derivatives way back in calculus 1. So delta x over 2 that will just give us 1 multiplied by, okay guys, g of -1, that's going to give us our g of x at -1. This is going to give us 10. Again, we're just basing it here. Okay. Plus 2. What's our g of 1 for this one, Wyatt? What's the value of our g of x? But still there?
3?
No, 1.
Wait, sorry. 1, 6.
So 6. Okay, Aliana, can you?
I was looking at the other way around.
That's okay. For the 3, what's your value of your g of x, Aliana?
1.
1, very good. And then Danny, what's for the g of 5?
8.
That's going to give us 8. So let's run it all down. That would just be 1 multiplied to 10 plus 12 plus 2 plus 8. That's just going to give us 20.
32.
32. Okay, so their total will just be equal to 32 square units.
Wait,
and I think,
Laura?
Yes. Yes.
Wait, never mind.
Okay. Any more? You sure you got it, Brandy?
Yeah.
Okay. Any more questions, guys? I'm so sorry we've been over for like 5 minutes. Questions, clarifications? You guys good?
Good.
All right. So again, guys, I'll be posting this one hopefully by tonight, just for you guys to give like a reference on your problems on Khan. And then have a wonderful night and see you next week.
Bye, Mr. Mora.
Yes.
Bye.
Bye, guys.
Bye.
Bye, guys.
Bye.
Have a
Thank you.
wonderful day, evening.
Don't go crazy being bored.
Yeah, I know. I'm go grab a. I think I'm gonna go for a walk tonight. Okay. See you guys. See you. Have a wonderful evening.
Bye.
Bye.
Oh, Mr. Omora, I forgot to tell you that I
Yes.
passed my placement test into calculus for my college I was going to, and I wanted to tell you that.
Oh, very good. Very good. That's good to hear. Congratulations. Are you gonna
thank
take?
you.
Okay. Okay. See you, Wyatt. Bye.
Bye.